All right, straightforward question. Is this a linear function? Show your work. We're going to find the slope 3 times. They did not give us a graph, so we can't just plot the points. So we're going to do slope number 1. If you need it, write it. So I'm going to use these first 2 points. I'm going to call this my x1, x2, y1, y2. So I've got 4 minus 1 for my y's and 4 minus 2 for my, 4 minus 2 for my x's. So my first slope that I get is 3 over 2. I will switch colors to do my second one. I'm going to use these next 2 points. It doesn't matter which points you use, okay? I'm going to call this my x1, x2, y1, y2. So for my second slope, I get 10 minus 7 over 8 minus 6. So I get 3 over 2. So far, so good. Last slope, slope number 3. Going to use these last points down here. I'll call these x's 1 and 2, these y's 1 and 2. When I plug it in, 16 minus 13 over 12 minus 10. That gives me 3 over 2 again. So, does it represent a linear function? Yes. The function is linear because the rate of change, ROC, is constant. That is it. That is all. Okay, practice problem 2. Is it linear? Prove your answer, explain. Okay, so this is why we learned all 4 criteria, okay? There is a way to graph this, but we don't know how to do that yet. So I can't graph it. There is a way to find the slope, but we don't know how to do that yet. So I don't know if my rate of change is constant. So which of those criteria am I going to look at, 3 or 4? We also don't know how to write an equation in y equals mx plus b form. So it's got to be the 4th criteria, which is I'm going to look at the exponent for my x. And remember, we need it to be 1. We don't write the 1s. So since there's nothing there, it means there's actually a 1. So yes, this function is linear because the exponent for x is 1. So this one was just kind of a can you rule out, you know, the ones you can't use, and there's only 1 left. So this function is linear because the exponent for x is 1. That is it.